Hi, my name is Tony. I've been doing Solidity for the last 2 years, and I specialized in helping companies and startup teams maintaining their software product quality. My real strength is my knowledge of Solidity and the ability to use assembly. Also, my experience in researching and experimenting with hacking cases so far, and that's what I'm passionate about. There are many known tips for gas optimization. However, whenever Ethereum forks a new version, the gas policy changes every time. Thus, it is necessary to track the changes so that the right optimization can be achieved.
Before Berlin, Axelrod had a fixed cost of 800. Now it depends on whether the storage slot was already accessed or not. If it wasn't accessed, the cost 2,100. If it was, it is 100. So an Axelrod costs 2,000 less if the slot is in the list of accessed storage keys.
What does it mean to Solidity smart contract developers? Before, they were avoiding writing storage variables except when absolutely necessary. For example, they first read the storage variable to a memory variable, do any manipulations on that memory variable, then finally write back to storage. After Berlin fork, you don't need that.
After London fork, one of the significant changes is the removal of gas refunds from self-destruct and the reduction of refunds from SSO from 50% to a maximum of 20%.
Gas tokens will become valueless. However, still, it is an incentive for developers to write applications that efficiently use storage and decrease redundant costs. Most smart contract developers are very aware of security issues and hacking cases and how to prevent them. However, sometimes it is necessary to consider how to deal with accidents and hacks that occur and minimize the damage. A few months ago, I helped a client who lost ownership of his smart contract accidentally because of a code-based bug. Another web was needed because the function to set the new owner was blocked by the old owner modifier set to an invalid address. The smart contract was manually manipulating the size of a dynamic array to reduce the amount of computation. Through hundreds of researches and experiments, I could manipulate the size of the dynamic array to be the same as the size of the storage, and after calculating the location of the owner variable, a new address was finally set. My research can be found on my GitHub. So, if you want to reduce transaction fees or resolve security issues, whatever, the solution always comes with assembly. I have experience in machine language programming using Intel and ARM instructions. Also, I have experience in implementing a Java virtual machine that was architecturally similar to the EVM. It just moved from an isolated platform into a whole decentralized network. I often use Solidity in an assembly using YOL, and at times I never hesitate to develop completely low-level smart contract using EVM opticals.